Let's explore the graphical element channels now. Channels are used to visualize the characteristics of marks. Some channels are shown here. For example, we can use the position channel together with the point mark to better show the difference between two data items. Or we can use the shape channel to make it easier to cluster similar data items together. Other channel options include color, tilt or angle, and size. We will look at the properties of these channels in a second. Before we do so, we need to have a solid understanding of the different data types that exist. There are two main types of data: qualitative and quantitative data. One class of qualitative data is nominal data, also called categorical data, where there is no inherent ordering between data items, such as between male and female gender, or between different ethnicities. Just think about it. If you had to plot ethnicities on a line from left to right, in which order would you arrange them? You could come up with many different arrangements since there is no inherent ordering. Another class of qualitative data is ordinal data, where there does exist an inherent ordering between data items, but we cannot measure the difference between them. For example, clothing sizes are clearly ordered from extra small to extra large, but it's not clear how much bigger each size is over the smaller one. Also, a Likert scale with data items such as disagree, neutral, and agree is ordered, but it's not clear how much gap there is between disagree and neutral and agree. In quantitative data, on the other hand, data items are ordered and we can measure the difference between them. One class is discrete data, where data items take on values on a scale with specified steps. For example, the scale for number of students would be full numbers, since we cannot have half a student. The price in dollar is also discrete data, but the scale would include steps of decimal points, since we can have a price of half a dollar or a price of 10 cents. Another class of quantitative data is continuous data, where data items are placed on a scale that has no steps. For example, a person can weigh just a hair more than another person. Time moves on consistently, and temperature can increase by the smallest amount possible. If you have trouble separating discrete from continuous, you can also think of watches. A digital watch has a discrete display because time increases in second steps. An analog watch, where the arms move smoothly without interruption around the dial, has a continuous display. We can get a better understanding which channel is suitable for which type of data by looking at the channel properties shown here. A channel has the selective property if it allows us to see the difference between marks. A channel has the quantitative property if it allows us to measure the difference between marks. This property is required to visualize quantitative data. A channel has the associative property if it allows us to group similar marks together. A channel has the order property if it allows us to order marks. This property is required to visualize ordinal data. A channel's draw count property is determined by how many unique marks we can make. The position channel is the strongest channel to visualize data and works for all data types due to its properties shown here on the bottom right. However, depending on how many data items are close together, the visualization may become cluttered and some data items will overlap others. Also, the position channel cannot be applied to spatial data sets where the data items are visualized on an underlying map, as their position is explicitly determined by longitude and latitude. Color, or hue, is a good channel for categorical data, but due to its low draw count and medium associative property, only a limited number of different classes can be distinguished by color. Since the channel does not have the order property, it is not suitable for ordinal or quantitative data. Also, some colors carry implicit meanings in different cultures, so that color maps can be difficult to design. Sequential colors, expressed in luminance or saturation, offer slightly better properties than color and thus can be used more widely. They are particularly useful if combined with other channels like position, length, or size. Yet the larger the number of shades used, the more difficult it becomes to distinguish between them. Due to its high draw count, the shape channel is an excellent choice for datasets with many individual classes. However, since it does not have the order or quantitative property, it is only suited for categorical data. Additionally, it highly depends on the shapes used for visualization, whether it is possible to group similar items. For example, by using shapes to display data about different vehicle types, we can display each type of vehicle such as a bicycle, car, or bus, by its own shape, and then group vehicles by the number of wheels. Grouping would not be so easy though if we are displaying emotions by emoticons. The tilt or angle channel has quite unique properties as shown here. Therefore, it is applicable only for certain datasets and is best used together with other channels. Since most properties are medium, this channel is not very expressive overall. Finally, the size channel includes dimensions such as length, area, and volume. They all have good properties, but while the interpretation of length is usually easy for the human eye, and the interpretation of area is okay, it can be difficult to compare volume for different data items.